All right, so when we've been talking about angles, knowing that they have an initial side and a terminating side, we have to realize, we can have negative or positive angles, and we can measure those negative or positive angles in degrees or radians. But what we're looking at here is coterminating angles. So these are angles that have the same initial side and the same terminating side, co-terminating. They share a terminating side, but their actual measure is not the same. And so notice here with this angle, well, we could get to this terminating side by going clockwise with that negative angle, or we could go counterclockwise with a positive angle. They would both have the same terminating side. Similar here, we start with our initial side. Well, we could make them both positive actually. We could have a nice positive angle right there, or we could go all the way around. That's 360 degrees plus some more. And so we could find co-terminating angles of a specific angle. Here's how we do it. If we have our initial measure in degrees, well, every co-terminating angle is going to be the initial angle plus any multiple of 360 degrees. And n isn't just a positive number. We're not just getting positive multiples. It's any integer. So we can have negative or positive 360 degree multiples that we're adding to our initial value. For radians, it's going to be any, again, n being an integer times 2 pi. Remember, just halfway around our circle is pi. 2 pi gets us all the way around. So 2 pi relates to our 360 degrees over here. It's going to be our initial angle measure plus 2 pi n. So let's see some examples of this. Here, if we have 45 degrees, we want to identify all angles that are coterminal to this one. Well, that's going to be 45 degrees plus 360 n, where n is any integer. Then we want to find and draw one positive and one negative angle that's coterminal to this one. Well, I'm going to let n first be a positive 1, just simple enough. That would be 45 plus 360, which would give me 405 degrees. If we think about the way this looks, 45 degrees, think about there's our initial side. 45 degrees would be right there. Don't act like you don't know where a 45 degree angle is. That's 45. This is an entire 90 degree angle going up the y-axis. So there's our 45 degree angle. This is our initial, and our starting from our initial to our terminating side. That's what we were given at the beginning, 45 degrees. But 405 degrees is positive, so we are going in this direction. But it goes all the way around 360 plus 45 to end right there at the same terminating side. Well, if we want a negative, let's let n be negative 1. It could be any integer that's negative, but I'm letting it be negative 1. That seemed simple enough to me. And so this is going to be 45 minus 360. 45 minus 360 gives me a negative 315. And so this will be very similar. There's my 45 degree angle. And 300, here's our regular 45 degree, that's what we started with. But negative 315 degrees, we go a negative 180, another negative 90, so this is negative 270, and then another negative 45, stops us right there at the exact same side. So that's when we're dealing with degrees. What about if we have radians? And this is a negative pi over 3, pretty interesting there. I'm going to go ahead and draw two coordinate planes that have negative pi over 3 on them so we can see that. A negative pi over 3, of course, we have our initial sign. But negative pi over 3 is definitely going down from the x-axis. And think pi is all the way to this, right back to the x-axis. It's half the circle. But negative pi over 3 is going to be a third of this. And so think about splitting this into thirds. And negative pi over 3 should be about right there. So we see that? We're splitting this entire side of our circle into thirds. Same thing here. This is also negative pi over 3. That's a little bit better. All right. So we've got our negative pi over 3, but we want to find all angles coterminal to this one. So this is going to be negative pi over 3 plus 2 pi n. We found all angles coterminal to this one, but now we want to find one positive, one negative. And so if I do the positive one first, I'm going to again let n be 1. For my negative, I'm going to let n be negative 1. For my positive one, this is a negative pi over 3 plus 2 pi. Get a common denominator. This would be 1 pi over 2 pi. If I make this a 3, I have to make this a 6. Yeah. So I multiply the top and the bottom by 3 to get that common denominator. And so this comes out to be a positive 5 pi over 3. Down here, if n is negative 1, well, I have negative pi over 3 minus 2 pi. And so that'd be subtracting 6 pi over 3. And this gives me a negative 7 pi over 3. And so think about this. When we're graphing our positive, I'm going to do that over here. 5 pi over 3, well, 5 pi over 3, that's 5/3 of this circle. We have 1/3, 2/3, 3/3 of pi. 3/3 pi right there. Because pi is 3/3. Pi, we're talking about counting by pi's. Here's 1 pi, here's 2 pi. But then we have 1/3 and another 2/3. That was 1, 2, 3, 4, 5 lands us right there. So that was 5 pi over 3. Down here, it's negative, so we're going in this direction. 1, 2, 3 gets us to our axis. That's 1 full pi, that's 3/3 pi. 4, 5, 6 gets us back to the axis where we started. That's 2 pi, 6/3, and then we have that last third, that 7/3, negative 7/3 around that circle, or around our coordinate plane in a circular formation, lands us back at that terminating side.